When you're revising correlations, think relationships. This is the key word or image to keep in your head, because that's what correlations are. They're types of relationships. Correlations measure the relationship between two or more variables, and what we're going to do here is go over the key things you need to revise to give a really good answer to a correlations question. So imagine we're looking at whether there is a relationship between the time students spend revising, T, and their grades in class, G. Data are displayed on a scatter graph like this, and two key words you need to remember with correlations are direction and strength. Direction is about the nature of the relationship. A positive correlation shows that both variables increase or decrease at the same time. A negative correlation shows that as one variable increases, the other decreases. Or there may be no correlation. Correlation coefficients are calculations that measure the strength of a relationship. And the closer the number is to +1 or -1, the stronger the correlation is. So the sign plus or minus tells you the direction of the relationship, and the number tells you its strength. And the mistake students make here is to assume that negative correlations are somehow less strong or less significant than positive ones, but they're not. For example, a negative correlation of 0.73 is a stronger correlation than a positive one of 0.45. The strength of the correlation is given by the figure. The great strength of correlations is they provide precise measurable data about the relationship between two or more factors. So, for example, is there really a relationship between time spent revising and exam grades? And if so, is it positive or negative? And what's the strength of that relationship? But, and it's a really big but, we can't say from this data that revision time causes the grades. And this is the really big question in correlation analysis. So just learn the mantra. Correlation doesn't mean causation. Correlation doesn't mean causation. Now, examiners will not only expect you to know this, they'll expect you to explain why. And here you can use imaginary examples, and that's fine, but it's even better if you can bring in a real research example, like this. A few years ago in the United States, parents were being warned about the dangers of letting their kids watch too much TV. And there seemed to be good reason for this. A lot of TV is violent, and a large-scale longitudinal study by Johnson and colleagues had shown a relationship between time spent watching TV as a kid and the likelihood of committing an aggressive act as a young adult. The data were clear and consistent. There was a strong, positive correlation. The more time watching TV, the more likely it was that the person would commit an aggressive act. Now that's a very interesting finding, but despite what some people were suggesting, it doesn't show that TV watching was a causal factor in the aggression. Remember the mantra, correlation doesn't mean causation, because both excessive TV watching and aggression might be the result of another factor, such as an aggressive personality, family dynamics, or socioeconomic status. But correlations can still produce valuable data which may suggest hypotheses that can be tested by further research. And here you can impress examiners further by adding that causation can be tested with an experimental design, where the effect of one variable on another can be tested under more controlled conditions. And although correlational research isn't usually brought into ethics questions, there may be ethical issues in socially sensitive research, such as correlations of ethnicity and intelligence, socioeconomic status and health behaviour, and so on. Exam questions on correlations can be relatively straightforward knowledge questions, or you could be asked to apply your understanding of correlations to a particular research question, or you could be asked to design a correlation, or maybe compare correlations to other methods. But whatever the question, the points we've covered here will help you to give a good exam answer. So remember, correlations are relationships between factors. They may be positive or negative. They can be strong, medium or weak. And although they may be suggestive, correlations don't establish causation. Correlations have covariables and not independent and dependent variables. And here you have to explain why and illustrate your answer. And if you found this revision clip helpful, then you can check out more shortcuts to psychological revision at shortcutstv.com.